You can see how we get a difference of squares, the factors that generate it. We start with conjugate pairs. So if we end up with difference of squares, to factor or to get the length and width, we will need conjugate pairs. And we can still do this, and with our area model, we know that we have x squared minus 49. And we know that these two terms must cancel out. So we need to find two numbers that multiply to 49 and cancel each other out, or the same but opposite. Well, that means that the 49 must be squared. So we end up with x minus 7, x plus 7. And so the plus 7x and the minus 7x is what's missing, and those are what cancels out. So when we factor this then, we end up with x plus 7 as our length, x minus 7 as our width. So it factors into its conjugate pairs. So we probably don't need to, if we recognize these as difference of squares, we can go ahead and write them as the square root. So x minus 9, x plus 9. And we can confirm this in our area model. We have our square, and we have our square here. We know that this diagonal terms cancel out. That means that we need the same length along here as we do along here. Well, the same length, two lengths that gives us 81 is going to be 9. So we end up with minus 9 plus 9 along here. And these are going to be the parts that cancel out. So here we don't have a difference of squares, because although we have a square here, that's not a square. We have a square here, that's not a square. So just a reminder, anytime we factor, factoring is not just quadratic factoring. Factoring is all types of factoring, including, number factoring and monomial factoring. Okay? Factoring a greatest common factor is the first thing we always do. So I'm going to factor out my a to start. Now that I factored out my a, what's left over here then is a difference of squares. I'm just going to maybe write that in a different color. Here is my difference of squares. I have a squared minus squared. So for x squared, negative 121. Okay, so we know that we have 2x long here, 2x long here. Has to be symmetrical, because again we need these parts to cancel out. So we need some symmetry here for that to happen. For this to be symmetrical, we need to take the square root of that. So we need 11 over on this side, 11 on this side. So this would have been minus 22x, positive 22x. That's what canceled out to give us the 4x squared minus 121. So now, once we factor out the a, and again, just a really important reminder that we have to factor the greatest common factor first. Now that we have factored the greatest common factor, we're left with the conjugate pairs as our length and width. So here, remembering that we have to factor the greatest common factor first. There is a common factor of 2. There's a common factor of a. And so what's left when we factor out the greatest common factor is x squared. Well, that's a square. 49, that's a square. B square, and that's a square. So we have our square minus square. If we have square here and square here, and opposite symmetry, negative here, we need opposite symmetry here. So again, we're going to have 1 plus and 1 minus. To figure out what terms give us this length here and this length here, that gives us a 49. It has to be symmetrical again, because these need to cancel out. So I need 7 here, 7b, and 7b here. So we have positive 7xb, negative 7xb here. There's where our canceling happened, and that's why we have no middle term in this bracket. So we found our length and width. So there's my greatest common factor. I need to keep track of that. X plus 7b, x minus 7b then gives us the length and width of the factor of the difference of squares. So again, reminder, we have to make sure we factor the greatest common factor. So I have to check my numbers, 20 and 125. The greatest common factor is 5. A squared, no a squared here. B, there's one B, one C, C here and here, and no D that's common. Okay, so then what's left over? Okay, so it's important to keep track of this. So we just divide. 20 divided by 5 is 4. No A. B divided by B cubed divided by B is B squared. The C's are gone. 125 divided by 5 gives us 25. BC is gone, and we're just left with D squared. Okay, so what we're left with then in the brackets is, this is a perfect square minus a perfect square. And when we have that situation, we have the middle terms cancel out. That means that this must factor into conjugate pairs with opposite symmetry for those middle terms to cancel out. So we take the square root minus the square root. And then we do the square root plus the square root. Okay, so that's important to recognize these. If we do end up setting these up as a quadratic, we should recognize right away that we are dealing with squared minus squared with these two terms canceling out. Okay, so these end up canceling out, so we need opposite symmetry here, which means that we must be dealing with conjugate pairs.